Good day, everyone. I am Audrey Ann Ibanez, Supervising Science Research Specialist from the UP Resilience Institute and project leader for the effects of extreme weather conditions on coastal concrete structures in the Philippines, determining appropriate concrete cover project. This project is a component of the interdisciplinary studies on concrete petrography, application on climate change, and resilience building program. It is co-implemented by the DPWH Bureau of Research and Standards and in cooperation with the agencies as shown in the slide. The project duration is 20 months, which started last June 2023. Concrete is one of the most used materials in construction worldwide. It is highly susceptible to durability issues or deterioration due to prolonged exposure and sensitivity to its environment. Changes in moisture and temperature may affect concrete's ability to resist chemical degradation, resulting in weakening and possible collapse of structures in extreme cases. Changes in concrete's environment during extreme weather events may be detrimental to old, large, and critical infrastructure such as seawalls and ports. A major durability problem experienced by these concretes is the corrosion of its steel reinforcement or rebar. This occurs primarily due to the infiltration of contaminants in the seawater, particularly chloride ions, and in the interaction of cement with carbon dioxide in the air, resulting in a process known as carbonation. Over time, further oxidation of the steel bars may create stress within the concrete, resulting to deterioration features such as cracks, spalling, and delamination. Structures exposed to salt water may also experience degradation due to sulfate attack. To increase the durability and prolong the service life of port structures, it is important to ensure the use of appropriate concrete cover thickness suitable to environmental conditions structures are exposed to. Our project has two general objectives. The first is to provide a comprehensive concrete quality assessment of coastal structures exposed to extreme weather conditions. The second is to determine appropriate thickness of the concrete cover and optimize make design for coastal structures in different Philippine microclimates. The results will be then used as an input for the development of construction standards of coastal reinforcement concrete structures. The Philippines currently has 4 microclimates and is the main basis for choosing the sample sites. 12 sites were chosen with 3 target sites per microclimate type, 2 of which are ports and 1 seawall. Other important considerations include exposure of some sites to past extreme weather events such as the Tacloban port for the Typhoon Yolanda. Shown in this slide is an overview of our methodology. We will begin with the conducting visual inspection through remote sensing and site investigation. Non-destructive testing may also be done at this stage to identify areas for concrete sample collection. Concrete samples will be collected using concrete quarry drill. Water samples at each site will also be collected and tested. Concrete samples will then undergo destructive testing, including compressive strength and point load testing. Other non-destructive testing methods will also be conducted to determine internal cracks and discontinuities within the samples. Finally, concrete samples will undergo concrete petrography to determine raw material composition, water-cement ratio, air void content, and other textural properties. It will also be used to determine degree of deterioration based on observable reaction products such as ASR gel and DEF for salt water attack, as well as the determination of the extent of carbonation on a microscopic scale. Water samples will be tested for the following parameters that will be crucial input for the corrosion prediction. Other tests to be conducted include XRD and XRF analysis for the mineralogical and major element composition. SEM will be used for detailed imaging of saltwater attack. Trial mix designs will also be done to determine the optimum concrete mix per area. From the collected data, corrosion initiation will be predicted through the modeling of carbonation depth and colorization, which will allow the determination of appropriate concrete cover thickness for different microclimates in the Philippines. Through this project, we hope to contribute the assurance of safety in both public and private works and reduce potential expenses due to damage brought by improper testing and misdiagnosis. Thank you.